The goal of Data Transformers podcast is to accelerate digital transformation by bridging the gap between business outcomes and rapidly advancing technologies. And we aim to bridge this gap by focusing on data. I am Peggy Tsai, top 50 women in tech influencer, co-author of the AI book, and data governance expert.
I'm Ramesh Danta, an entrepreneur, a tech blogger, and AI enthusiast.
Hi, everyone. Welcome, Fiona Browne, to today's Data Transformers podcast. I'm so happy to have you on, Fiona. You are the head of AI at Datactics. And what really struck me, Fiona, was the fact that there is an actual, there's women in that can hold the title of head of artificial intelligence. And we really look to highlight and really want to profile women of your caliber. Can you first talk to us, Fiona, about how you even got started in this journey of AI? Where, as a child, did you know this is something that you wanted to do? How did you get into this field?
Well, thank you very much, Peggy, for the introduction, and also thanks, Ramesh and Peggy, for inviting me on to your podcast today. I'm very excited about this, and to maybe give a bit of a background to how I got to Datactics and my journey there. I think what I would say at the outset is that it wasn't a linear journey. It was more a little zigzag approach to where we got today. But I suppose it all started back whenever I was about 15, 16. Peggy, and you asked about, as a child, were you interested in AI and machine learning? I don't think that was even on the radar at that stage. I suppose I'm showing my age at present. But yeah, it started back whenever I was about 15 and 16, and I was deciding what GCSEs to take. So I'm not too sure how that maps to the US, but in the UK here, we do GCSEs and A-levels before we go on to university. Mm-hmm. And at that stage, I had an option of doing history, or I had an option of doing this relatively new computing GCSE. And I talked to a few people, and I made a decision. Do you know what? I'm going to try computing. It seems to be an up and coming subject, and from that I did the GCSE. Absolutely loved computing and mathematics, and how the two blended together. And then ended up doing it for my A-levels as well, and then that brought me into a degree then in computing. But what I'd like to highlight there as well is that I came from an all-female school, so both my primary and secondary education were in all-female schools. And I had a brilliant computing teacher called Mrs. Coyle, who knew her area inside out and back to front, and really give us the confidence as a class to excel within computing. And it never once crossed our minds that we're females, and this is quite a male-dominated subject. It just never came into our conscious state. And then from that, we all did well as a class within the computing subject. We were covering things like programming and databases and networks and so on. And I was just fascinated by the area, and it was a no-brainer then to go on and do computing at degree level. Mm-hmm. So way back in 2000, I embarked on a computer science degree at Ulster University. And yeah, that was a bit of an awakening and a bit of a shock to the system coming from an all-female school.
So it was a co-ed university.
Yeah, yeah. So it was going from from an all-female school for like being in education for 18 years to essentially a very male-dominated class. So there was probably maybe 10 to 20% of the class who were female, undertaking computer science. But I don't think we really batted an eyelid. We just sort of got on with it, and it was such a good course because we went into much more depth in areas in terms of algorithmic programming and software development and testing and human computer interaction. It was, really broad and varied, and we got to focus on areas that we were interested in. And sorry, I'll let you, if there's any questions, to chip in.
So it's a very interesting way of deciding between history and computer science. So this is probably, you're the first person that I came across that has said, I have to either take history or computer science, but I chose computer science. Okay, that's phenomenal.
Yeah.
So then you went to Ulster, you got your computer science degree. Did you do your PhD right after your degree, or did you wait for some time?
No, so I actually got to undertake a placement whenever I was at Ulster, and I got to work for a year in Intel, which is just based outside of Dublin in Ireland.
Actually, I have to interject. I worked at Intel, so I know.
Oh, yeah, both colleagues.
Yeah. So yeah, Ramesh, you'll know that it's such a great place to work in.
Exactly.
In Intel, and I think as like a 19, 20-year-old getting to work in this really large multinational company, and you worked on real projects, and you were an integral part of the team. It was just a phenomenal experience to be able to work there. And I worked in a place called Flex Services, and it was like an internal consultancy within within Intel. So yeah, we were exposed to like the whole world as such. So a lot of our clients were Intel, but from different countries and so on. And you got great exposure in terms of working with diverse teams, really interesting projects that we were working on, through to, I think what the key learning from Intel was, it was honing your soft skills. So within education, you focus on a problem and solving that problem. But within Intel, what was really highlighted there was, okay, you need to be able to work as part of a team. You need to be able to communicate. You need to be able to work to deadlines and to focus on priorities and so on. So as a young person going in and being exposed to that, I just think that was just phenomenal learning within that year, and also being exposed to the diversity of IT roles available as well. So it was a great placement.
So, I mean, it sounded like you had such wonderful training as a young girl. I mean, in university and in Intel, it taught you all the skills to be a really well-rounded data scientist. And but can you talk about any challenges that you had, or anything that you overcame as a hurdle that might have surprised you, or that you're proud of being able to overcome?
Yeah. So I suppose some challenges, which I suppose were completely out of my control. So So I graduated in 2004, and that was just at the end of the dot-com bubble. So the dot-com bubble burst, and we graduated out into into a sector which was essentially licking their wounds from the inflation of the IT bubble. So I think that was our first challenge in terms of, even having good skills and good experience. It was a tougher environment to get a job in. And I was very lucky that I got a job as a web developer whenever I graduated. And this was like the polar opposite of Intel. It was a tiny company. There was less than 10 people in the company. And I don't view this as a challenge. I view this as a real positive. It was a very small company, but in terms of gaining skills, the amount of skills that you can obtain in a small company is massive as well. Unlike Intel, we didn't have somebody who looked after servers or somebody who looked after, liaising with clients. Within a small company, you basically have to get stuck in at the deep end and do it all. And that's a great learning experience. So my first day, I landed within the company. So it's a place called Design by Front. I was told to, construct your own computer here. So yeah,
Construct your own computer.
Yeah, so it was literally. So it was literally, here's the motherboard, and you basically build your computer around that. Whereas in a larger corporation, whenever you're being onboarded, all of that's done for you. But yeah, so you do get a different learning opportunity there, and I suppose probably again, not necessarily a challenge, but probably one of the hardest things that I ever did was firstly making the decision to leave industry and go back into academia and undertake a PhD. So my PhD was it was computer science in Ulster University, and it was in the area of bioinformatics. So this is sort of my first taste of using statistical and machine learning models to make predictions. And we were making predictions on protein-protein interactions. So proteins are like the building blocks of your body. And whenever these interactions between proteins go wrong, that can lead to disease and so on. So it's a really interesting area to look into. And the challenges that we had in this wasn't necessarily with the models that we were building. The challenges we had were around the data that was there. So you have all these high throughput experimental approaches like assays and so on, which are fantastic in giving you information about genes and their expression and so on. But they're often, they've got a high rate of false positives, false negatives. They're messy, they're large in size. So that I suppose was the real challenging part of the PhD. And again, I was so lucky to have fantastic mentors on my PhD. So my supervisors were Francisco Azuaje, who's currently the Associate Director of Data Science at UCB, and Professor...
I'm sorry, you said UCB, which one is that?
UCB, it's a global biopharma company in Belgium.
Okay.
And Professor Jane Sang and Haiying Wang were my other PhD supervisors. And I'm forever grateful for them, because what they did was they instilled rigor and scientific discipline into me from a very early stage within the PhD project. And it's this rigor and discipline that's basically stayed with me throughout the rest of my career. And it really opened my eyes to the absolute importance of being very skeptical about the data that you have, and rigorously testing your processes and looking at that from a statistical standpoint as well. So I may not have initially thought it whenever I would have come with my nice results and I was getting, for example, very high accuracy results. And, my supervisors were like, okay, that's accuracy. What about your precision recall results? What's that look like? And I come back with these results and like, okay, well, what's happening at each fold of the cross-validation that you're running? And I'm like, oh, really? Do I have to really go back and do this? Yeah. and the answer was yes. And that's sort of the same sort of level of detail which I carry through now and ask of my current team. So I'm sure they curse me up and down, but but I think it's that rigor that you need, because there are lots of things that can go wrong, and it's really important to take your time and to be careful, and to have a healthy dose of skepticism whenever it comes to machine learning and interpretation of results.
Yeah. So on this journey, so Fiona, how did you end up at Datactics? That's one. Or did you stop somewhere else before you ended up at Datactics?
Yeah, so I had another foray into industry again. So I was hired as a software developer at a company called PathExcel. And this was straight after my PhD, and it fitted really well because this was a spin-out company from Queen's University, and their focus was on virtual microscopy. So it had that biological background and a proper, software engineering focus as well. So essentially, we developed software for like an online microscope. And being able to view and subsequently analyze microscopy images. So it was super interesting work that we were doing there, and a very hard slant on the software engineering side, and again being able to skill up in that area again, and being introduced to industry programming practices as well. So like things like how to test your software, and through to how to manage a software development project and different principles along that. So that. And
did you bring the data rigor that you learned in your PhD to the industry?
Yeah. That's do you know what, that's something that will continually follow me in a little suitcase wherever I go. It's just whatever you build, the most important thing is having your data in order. Otherwise, anything else you do on top of that is potentially meaningless. So
I'm assuming that you didn't have to build a computer in this company.
No, they're really nice. We're on a couple of years now, so we didn't have to worry about that. And because like the data that we were handling there, like these images were massive. So you're talking like a cytology smear being maybe 25 gigs in size. Most of our work was done on servers anyway. So it was really interesting. And actually, this was where I met another mentor and another important person in my career life, Stuart Harvey, who headed up PathExcel. at that time. And Stuart, I think, took a risk on me, because here I was coming out of a PhD in the bioinformatics area. I had some coding experience, and he actually hired me as a software developer in C#, and I'd literally only dabbled in that. But he's very good at spotting the potential in people, and in people curation is what I call it. So yeah, he gave me a chance at this, and he was right. Within a couple of months,
Yeah,
you could pick up another language.
that's cool. That's very nice. So, and then afterwards, Datactics or anything else happened?
Well, afterwards it was back into academia for a bit. So I did a postdoc in Queen's, and then I lectured then for 5 years in computer science at Ulster University. So it was being able to bring my learnings and knowledge of industry, practical implementation of software,
Yeah.
into academia. And then I also got to work with what I'd done in my PhD, the whole area of handling data, which is messy, which is potentially conflicting, and how to handle that and how to integrate that together for decision-making purposes. This also then led to our work in networks as a way to integrate data together and to analyze and view relationships. So
Can you talk? Yeah. Fiona, can you just share what things you talked about in academia about data being messy? And I mean, can you dive a little bit deeper? Because I think in our podcast, we really try to highlight the importance of data here. So I really find this quite fascinating to go deeper.
No problem, Peggy. So yeah, so within academia, I worked in different sectors. So worked with the bioinformatics sector and also in the aerospace sector. And I think so you're thinking, okay, these are very, very different areas. How could you possibly work in both? Well, these areas share a lot of similarities in terms of the underlying data that is used. So unfortunately, not all data is created equal. So you could have sources of information, for example, within the bioinformatics domain, that people are using to make decisions as to whether or not a gene therapy or a therapy is good or not.
Mm-hmm.
But you're working with data in that the experimental outputs, they mightn't be perfect. And you can have maybe another experimental output looking at a completely different area using a different approach, which conflicts with another data source that you're using. Yet you need to use these data somehow and together to make an informed decision, and how can you do that? So our area is really focused on, okay, you've got these large data sets. They are messy in terms of false positives and false negatives. And they are potentially conflicting with each other. Well, what can we do to help a decision maker here?
Mm-hmm.
And we were looking at things such as Bayesian networks to integrate these data together. So what it was quite good at is whenever you integrate data together and you have more than one source supporting a particular, for example, prediction or a particular outcome, then you can have more confidence that you're on the right road here. through to using Dempster-Schaeffer's theorem. So that's where you can actually then model confidence and belief that you have with your data as well. So say you've got different data sources, and you've got a particular source, say for example, so you've got some sources, say for example, are like journal sources, and you know that they've gone through a rigorous peer review process, so you can have some confidence in the results that they have, through to maybe a blog post that is unverified and we're not too sure about this, but yet it could contain some useful information, or it could add some color and context to what we're trying to do. How do we integrate these all together? And there's different ways in terms of different discounting techniques and adding different beliefs and strengths and so on to the sources that we're reviewing. And I think this type of work can be applied to many different sectors. So I don't think there's any sector that's sort of free from from the challenges around data in terms of its quality and accuracy and so on.
So with that, transitioning into the data side, Fiona, so what does Datactics do, and what's your role at Datactics?
Yeah. So Datactics, we specialize in data quality and matching at scale. We're a company based in Belfast, and there's about 50 plus of us and growing. And we've got a presence also in Milan and in London. So our clients are primarily in the banking, finance, and governmental sectors. And we help our clients with things like profiling the data, measuring the quality of their data, through to matching and deduplication of their data. And this is important for tasks such as onboarding clients, through to adhering to regulatory to regulations.
And then I think one of the things that I was looking at Datactics is it's about a self discovery or self-analytics, self-service analytics. I meant self-service data quality. It looks like that is the big deal for Datactics.
Yeah. So I suppose that's sort of our unique position in that. So we try to have, so we've got a self-service data quality platform, and it's low to no code, and essentially it's putting the data quality tools in the hands of the subject experts, subject data experts. So it enables them, to rapidly measure the quality of their data, to report and to fix their data then as well, all through like quite an easy to use interface. And also to be able to build their own data quality rules and deploy those as projects, and then to view how their projects are running. So it's that idea of low code, no code, and enabling the people who are actually at the coal face managing the data to be able to use this type of functionality without having to have a software engineering background.
Thank you for listening to today's episode. If you liked what you heard today and would like to hear more, please subscribe to our podcast on your favorite player like iTunes and Spotify. And please do rate our podcast. Also, please go to our website, www.datatransformerspodcast.com, for more episodes, blogs, and information on our speakers. Thank you.